We do part C, solving poly equations. Calculate all the roots for the polynomial. First thing is finding your list of all possible rational roots using our rational root theorem that we normally refer to as our P's and our Q's. So reminder that P is going to be a list of all the factors of our constant, and Q is going to be a list of all of our factors of the leading coefficient. So with that 252 being a large number, we're going to have a very long list. And so you could, of course, can start using your calculator if you need to when that happens. And you would just start doing like what we used to do in the old days in Algebra 1, and we would divide by 1 and see if it would work. Of course, 1 is always a factor. Because I'm writing larger so that you can see it on your screen, I'm going to kind of lead into that other side, but you should have enough room writing normal. So 1 and 252, and then I would divide it by 2, and I would say 2 and 126, and then I would divide it by 3, and I'd see 3 and 84 also work, and then 4 and 63, and I might have to make even more room. I know 5 is not going to work because it doesn't end in a 5 or a 0. 6 does work. 6 and 42. Oops, that should be a 7 and 36. Let me scoot this down just to make some room. So we said 7 and 36. Let's try 8, 9 and 28. Might have to make even more room. I know 10 will not work. It doesn't end in a 0. 12 and 21 does work. And we keep going until the numbers start to repeat because we don't have to repeat numbers on our list. Looks like 14 and 18. Of course, I did pick a very large number just to give you some practice skills. Yours won't be as big. You'll see that on your example, it's a little bit more friendlier. But I wanted to remind you of strategies that y'all used to use in your prior classes that do connect. So you got 14 and 18, and then I'm going to keep going until I start repeating. So 15, 16, you got to go until you get a whole number, 17, and then boom, I just hit 18, and 18's on our list. So it was a very giant, long list of numbers here. I am going to move them around just so that it fits on our screen as we move forward. But again, ideally, these would all be in one line so it's easier to see. All right, so that's all our factors of P. Q is going to be very friendly because Q is the number 1, and there's only 2 factors that work for 1, which is that plus or minus 1. So from there, you would take every numerator and divide by that denominator, which in this case is easy because anything divided by 1 is itself. So 1 over 1 would be 1, 2 over 1 would be 2, 3 over 1, 3, 4 over 1, and so on. So basically at this point, we are just rewriting our final list of simplified possible rational roots. Now, in the old days, when you were not allowed to use calculators, you would have to start running your next step, which is synthetic division, to see which of these is actually a root or an x-intercept of that graph. Now look at this long list. Imagine having no calculator and having to do synthetic division over and over and over and over again until you found one that gave you what you need, which is a remainder of 0. So because this is our introductory lesson into this, we will use our graphing calculator to help us decide which of these numbers are we actually going to run our test with using that synthetic division that we learned in this lesson from 3.7. So you will type in your polynomial however they give it to you, and then you're going to graph it, and you're going to look for your x-intercepts, and you want to run tests only with whole numbers. So on this one, I do see 2 possible whole numbers. It looks like your graph is crossing at -6 or 6, which I do see on our list here. And so you can run your test with either one of those numbers, the -6 or the +6, and see if you get a remainder using synthetic division. So just for funsies, I'm going to pick the +6 to set up the synthetic division to run my test. I do need to make sure, though, that when I set up for synthetic division, my original polynomial, which I'm going to highlight so it doesn't get lost, has to represent any missing degrees. So with my highest exponent being a 4, I should have an x cubed behind it, and I don't see that right now. And so I would say that I have 0 x to the power of 3. I do have x to the power of 2 given, but I do not have an x to the power of 1, and I do have my constant with x to the power of 0. So the coefficients that we're going to use for this synthetic division are 1, 0, -29, 0, and -2, 52. So let's write those numbers left to right into our synthetic division setup. We can do second quit and use, because we got some larger numbers here. But remember, our first move is we're going to drop down that first number, and then we're going to start our steps and multiply, add, and drop. So we're always going to multiply by that 6 on the outside. So 6 times 1 becomes the number 6. Then we're going to add straight up and down. 0 plus 6 is 6. And we start our process over again. Multiply 6 times 6. We're going to add -29 plus 36. And we're going to drop it down, multiply, add, drop, and I'm definitely going to use my calculator here. We're going to multiply, add, and drop that down. Because our remainder is 0, that means 6 is definitely an x-intercept. So we do have one of our zeros. Now, don't forget that we should know how many zeros we have from this degree. So we should have 4 different x-intercepts. We only saw 2, so that's a pretty good hint of what some of those final answers are going to be. From here, you're going to rewrite your polynomial, because we had a degree 4 originally and we just took out one x. That means we're going to have one less degree. So instead of an x4, we're going to have an x power of 3, and then you're going to count it down standard form style. And so when we rewrite this, 6x cubed, when we rewrite this, that should be a 1x cubed plus 6x squared plus 7x plus 42. So the next round is up to you. You have 2 possibilities. Because this graph did have another whole number, you can do a second round of synthetic division with this new quotient, or you can factor this quotient. And so factoring with this one would definitely be a grouping with those 4 terms. Our GCF of the first 2 would be x squared, and when we divide that out, we would get x plus 6. Your GCF of the second side would be a positive 7, and we would divide that out, we would get an x plus 6. And so because those remainders match, that means we're good to keep going with our grouping. And let's regroup our GCFs together into one factor, and then our matches into another. And then we would take each of those factors, set them equal to 0, and we would solve for those last of those x's. So here you can definitely see that -6 was correct. So I'm going to add that to my list here. I've got 2 out of the 4, so we need to find 2 more. So this x squared plus 7, when we subtract the 7, we get a negative. And when we go to square root, remember that when we're solving, we should put our plus minus symbol. Plus or minus the square root of negative 7 is not proper form. And so we would want to bring it out as plus or minus I square root of 7. And when we write those separately with our positive I root 7 and our negative I root 7, we do have our final 4 solutions, with those first 2 being rational. They are real and can be written as fractions. And those last 2 with those i's, we would call them complex because they have that imaginary unit.